Okay, so in this video we're going to be looking at the sine and cosine functions and what it looks like when we graph each of those functions individually. So to start us out, what you're going to do is you're going to work on filling out this table. So they've already started it for us, so we're going to use the approximate solutions to each of these. So for example, the sine of 30 degrees would be 0.5. They did 135 degrees, sine of 135 is 0.707. The sine of 300 is negative 0.866. So go ahead and complete this table. And when you complete that table, what you're going to do next is you're going to graph it on this grid. Now they've already graphed the first 5 coordinates for you. So we know that when when the angle is 0 degrees, the sine of 0 is 0. We know that the sine of 90 degrees is 1. And we know the sine of 45 degrees would be square root of 2 over 2, which you're going to get here as your answer. Sine of 30 degrees is 0.5. Sine of 60 degrees is square root of 3 over 2, which you're going to get the decimal answer there. So they've already graphed these first 5 coordinates for you, but you're going to graph all of these from the table. So again, the x-axis represents the degree value. The y value represents the value of the sine of that particular degree. So why don't you guys pause the video so that way you can do this activity and again fill out the table and then go ahead and graph that data. So pause the video, hit play when you have this front side all completed. Okay, so let's see what you should have done here. First off, you should have your table. Double check your answers here. You should have gotten these answers if you rounded to the nearest thousandths place. And then when you go to graph it, your graph should look something like this. So when you go to connect it, your function, the graph of that function would look like this one. Now this is what we call the sine wave, and it's important to understand what the graph looks like. Now you're not going to have to remember every single point in detail, but the ones that you want to make sure that you're familiar with are the x-intercepts. So if you notice, the sine wave here, the sine function, when you graph it, starts out with an x-intercept of 0 and a y-intercept of 0, has another x-intercept of 180 and another x-intercept at 360. It has a maximum value in that first interval of 90 degrees, or at 90 degrees, when so its maximum value would be 1. It's got a minimum value of negative 1 when it reaches 270 degrees. Now these other values in here are radians. We're going to talk about that at the end of the chapter. Now if we were to extend out that function, when we graph it, you would get this wavy line. We call this the sine wave. We'll get to that here in a minute. But a couple of terms to be familiar with is this term of a period. A period is one interval, one full rotation, so to speak, on the unit circle. So what this represents is how long it takes to repeat itself is one period. So for the sine function, repeats itself every 360 degrees. And again, it's important to recognize that it starts here at 0 and then goes up. After 90 degrees, it gets to a peak of 1. It's got its next x-intercept at 180 degrees. It reaches its minimum value at negative 1, and then it reaches back to another x-intercept at 360 degrees. And then you can see that it repeats itself again, or we could even go backwards. And it goes backwards here to the left of 0, and you can see that it's continuous here. Now, the cosine function you should also get in your notes. At least this first interval goes from 0 to 360 degrees. So again, every 360 degrees it repeats itself. So it says that it is, we would say that it has a period of 360 degrees. But this one's a little different. This one here, instead of starting at 0, it starts up here where the y-intercept is at 1. So in other words, the cosine of 0 degrees is 1, which if you remember from your unit circle, that is true. The cosine of 90 degrees, that's 0. The cosine of 180, that's negative 1. And then the cosine of 270, that's also 0. And the cosine of 360 is the same as 0, which is 1. So this is what the graph of the cosine function would look like. It's very important to know how to graph these on your own without a calculator. You'll be asked to do that on a quiz and or a test. So be familiar with the shape of these graphs. The key points are these 5 points that I've indicated here. Those are some 5 key points. Because if you can remember those 5 key points, you're going to remember that it just repeats itself over and over and over again. These are some properties that we just looked at. The domain for both of these functions is going to be all real numbers. The range is going to be the same. They alternate between -1 and 1. The x-intercepts represents the odd multiples of 90. In other words, odd numbers times 90 would be your x-intercepts. In other words, 1 times 90 is 90. 3 times 90 is 270. 5 times 90 is 450. So we call those the odd multiples of 90 degrees. The x-intercepts for the sine function are going to be the even multiples of 90. So 2 times 90 is 180. 0 times 90 is 0. 4 times 90 would be 360. So with the even multiples of 90, so even numbers times 90 would give you x-intercepts for the sine function. Both of them have a period of 360 degrees, and a cosine function has a y-intercept of 1, so it starts at 1 there on the y-axis, and the sine function has a y-intercept of 0. Now, if you were to strip away everything except for the graph for these two, so if you strip away all the lines, the x-axis or the angle axis and the y-axis, if we were to strip that away, so we're just looking at the graph, you'd see that they're the same graph, just shifted 90 degrees. So these two graphs are going to be congruent to each other. So therefore, since they're essentially the same graph, we call these sine waves. So we don't have a cosine wave. There's no such thing. They're both sine waves. It's just that this cosine function is the same wave, just shifted 90 degrees. Now, if we have any story problems that lead to sine waves, we call those sinusoidal. So a sinusoidal example is going to be what we're going to look at next, dealing with the Ferris wheels. So let's look at the story problem. It says the Great Ferris Wheel, built in 1893 for the Columbian Exposition in Chicago, had a 125-foot radius and a center that stood 140 feet off the ground. A ride on the wheel took about 20 minutes and allowed the rider to reach the top of the wheel twice. Assume the ride began at the bottom of the wheel and did not stop. Which sine wave below models the rider's height off the ground a certain amount of minutes after the ride began? Now, before we just jump into figuring out which graph it is, there's some things we need to understand. So first off, let's draw a diagram so we can better evaluate what's going on here. So you have a Ferris wheel that has a radius of 125 feet. That means no matter where you go, from the center of the circle to the outside of the circle, it's got a radius of, or distance of 125 feet. They said that the center of the circle stands 140 feet off the ground. So now oftentimes they're going to ask you, what's the maximum height that a rider would reach? Well, the maximum height would be up here. Now, a lot of people would say, well, that's going to be 250. Well, 250 is the diameter of the Ferris wheel, yes, but that is not how high it's going to be off the ground, because this distance from here to here is 140. This distance from here to here is 125. So together that makes 265 feet. So a rider would be approximately 265 feet in the air at its highest point. Now, if they ask for what's the minimum height, or what's the lowest a rider would reach, well, in that case, we're going to look at, well, the fact that from the center to the ground is 140 feet. I know from the center to the bottom of the wheel it's 125 feet. So again, if I subtract these two this time, I'm going to get a total of 15 feet. The way that we did that is we take 140 minus 125, and that gives you 15 feet. Now, if they ask you how long is one revolution or one period, so one revolution would end up being, now remember they said that a rider is going to ride on it for 20 minutes, but that allows the rider to reach the top of the wheel twice. In other words, you go 2 times around in 20 minutes. So it means one period would be 10 minutes. So let's figure out which one of these graphs match all this data. So the first one here does not have a maximum height of 265, so it's not graph A. This one has a maximum height, it looks like a 265, but its minimum is at negative 265. So that's not going to be an option because our Ferris wheel is not going to go below the ground. Here it looks like our maximum height is at 250. Its minimum value is at 15 feet. And if you notice, after 0 time has gone by, you're going to get on the Ferris wheel at 15 feet. So there's going to be a platform you're going to have to go up. And then the Ferris wheel goes around, so you get up to its highest point of 250 feet after 5 minutes, and you swing back around after 10 minutes. So one full revolution is 10 minutes, and you go around again, and then you get off after 20 minutes. So graph C would be your answer. Let's look at it from a different perspective. This time it says, suppose a bird lands on a Ferris wheel basket at the basket's highest position and rides for one complete revolution. If the Ferris wheel has a diameter of 180 feet, the center of rotation is 100 feet above the ground, and the wheel takes 10 minutes to make one revolution, which sine wave below models the height of the bird t minutes after it lands on the Ferris wheel? So here again we have a Ferris wheel. This time it's got a diameter of 180 feet. So that means it's got a radius of 90 feet. And it stands 100 feet, the center stands 100 feet from the ground. So the maximum height here would be 190 feet. The minimum height you would reach, the bird would reach, would be 100 minus 90, which is 10 feet. And one period, or one revolution, would be a total of, they give it to you as 10 minutes. But remember, the bird landed at the highest peak here. So there's a little bird. So our bird landed at the highest point, which is at 190 feet. So that's where it's going to start for this one. So that's why graph B would be your answer. Because this one starts at 190, gets to its lowest. The lowest height would be, I think, it must have been a typo here because this should be 10 feet. So this technically would be, so again, I should have changed that maybe to 110 feet. I think that's a typo. There. Now your minimum would have been 20 feet. So now your minimum is 20 feet. So that's what we reach here. And then the bird, after it reaches its highest point again, is going to fly away. So that's why graph B would be your correct answer. So the most important part for this section is to make sure you understand these Ferris wheel problems, how to get them set up, how to think about them there. And remembering those definitions that a period is referring to one revolution or how long it takes to repeat itself. And then you want to make sure that you're familiar with these two graphs, the sine function and the cosine function. So with that, good luck on today's assignment.